Hi everyone, welcome back. Let's continue to look at more geometry in space. Example, find the shortest distance from the point 5, -4, 12 to the followings. So let's plot these points in our space. So we have X, Y, Z axis. So x coordinate 5, so 5 is here, and then -4, which means we go to the opposite y direction 4 units, right? And then it will be like this point. And then we go up 12 units. Let's say this is 12 units. Okay, then this is the point 5, -4, and 12. Okay, what is the shortest distance from the point to the xy plane? See, this is the xy plane. What is the shortest distance? 12, right? So this guy is like the projection of the points on the xy plane, right? And the distance between them is 12. How about the YZ plane? YZ plane is right here. Okay, so what is this guy? So this guy is like the projection of the point on the YZ plane. And this guy is the same as this length. This length is 5. So far so good, everybody? Let's continue. So let me erase so many lines here. Okay. Next. XZ plane. Where is XZ plane? Is this guy, right? And the projection, imagine the projection of the point on the XZ plane is gonna be this guy, right? What is this distance? Well, this distance is the same as the y distance, right? It's -4, so the distance is 4. So far so good, everybody? Okay, let's continue. So when we talk about projection, you can imagine, well, we have a picture right here. There's a sun right here, okay? And there's a bird flying. I don't know how to draw a bird. And then where is the shadow? So this is the shadow, right? So this guy is like our points. This is like the projection of the points. Can you imagine this picture? Okay, let's continue. The x-axis. Where's the x-axis? Right here. Okay. So what is the closest distance? Well, it is this guy. And so this is the point, right? The closest distance from this point to the x-axis is this line segment. How do we calculate this line segment? Well, you see this right angle triangle, okay, and we have this side is 12, this side is 4, and then what is this guy? By the Pythagorean theorem, the distance is 4 squared plus 12 squared. 4 squared is 16, 12 squared is 144. So we have square root of 160. So this is the same as 16 is 4 square, right? So 4 times square root of 10. So this is the shortest distance to the x-axis. Okay, so far so good. Let me erase this triangle because now let's look at to the y-axis. Where is y-axis? Right here. Okay, right here. What is the shortest distance? Well, this guy, right? This guy is the shortest distance. And let's draw this right angle triangle. Well, this is 12 and this is 5. Well, what is this distance? By the Pythagorean theorem, 12 squared plus 5 squared, 144 plus 25. What is that? Well, that is 169. Well, that's 13, right? Do you remember there's some like common right angle triangle? They one of them is the 3, 4, 5, right? The other one is the 5, 12, 13. Okay, so if we see the other two sides of these guys, then we can know what is the remaining side of the right angle triangle. Okay, let's continue. And can I erase this part? Okay, let me use a different color now. What color haven't I used? How about blue? Okay, z-axis. So this is the z-axis, right? And we have this point here. Let's see. Okay, how do we measure it? Well, let's look at this guy. This is the projection of the points to the YZ plane, right? We can consider these right angle triangle. Then we have, this is 5, right? And then this guy is 4. Okay, what is this guy? By the Pythagorean theorem, 5 squared plus 4 squared. What does that say? That says 25 plus 16, which is 41. Okay, so that's the distance from the point to the z-axis. So far, so good, everybody? Okay, good. Let's continue. All right. The next problem, we want to identify each of the following as a sphere, a single point, or an imaginary object. Okay, now let's see what happened. Okay, so do you remember in R2? Well, circle, we have the standard form x minus h squared plus y minus k squared equals r squared. We have the center is hk with the radius is the r. So far so good, everybody? So this is in R2 xy plane. How about in the space? Well, in the space, instead of circle, we're gonna have sphere. Well, sphere is in the form of x minus a, y minus b, z minus c, the radius still r. Then we have the center is a, b, c, r is still the radius. So far so good, everybody? So in this case, we want to express all of those equations in the form of the sphere. Okay? So which means we need to complete the square. Okay. Do you still remember how to complete the square? Alright, let me write it down here. So let me remind you that, so to complete a square, keep in mind that a plus b squared is a squared plus 2ab plus b squared. A minus b squared is a squared minus 2ab plus b squared. Okay. So let's come back to our problem and start. So part A. Okay, so first we group the x terms together. So x minus 4x. And then we have y squared plus 10y. And then here we have z squared minus az. And then we have minus 54. So far so good? Okay, what number do we want to add or subtract here? Okay, let's compare. Okay, let's compare. So here, this guy, it looks like a is my x, and then we have minus 2ab, so minus 2ab equals minus 4. Then and a is x, so x cancel, minus cancel, so 2b equals 4. B is 4 over 2, which is 2. Okay, and actually b is always the middle coefficient divided by 2. Okay, so in this case, minus 4 divided by 2 is minus 2. Well, then here, what do you want to match here? You want to match a b square. Let me use a different color. So here, we want to match a b square, so we want to match a minus 2 square. Well, minus 2 square is the same as 4. If you add 4 to the left-hand side, you also need to add 4 on the right-hand side. Okay? And here, what do you want to match? Well, you want to match 5 divided by 2, which is 5. Okay, sorry, 10 divided by 2 is 5. So here, you want to match a 5 square, right? Okay, so 5 squared is 25. Let's continue here. Negative 8 divided by 2 is negative 4. So here you want to match a negative 4 square. Well, that's the same as 16. So far, so good, everybody? Okay, what is our answer? So this is x. We'll put the minus 2 here. This is the complete square. This is y plus put the 5 here, complete square. Z, put the minus 4 here, complete square. So we have the right hand side, minus 54 plus 4 is minus 50. And then 25 plus 16 is 41. So we have minus 9. Well, you see all on the left is square. Square is greater or equal to 0, but on your right hand side is negative. So this is impossible. So it's an imaginary object, or you can think of a complex number. So far, so good. So no real objects associated with it. Okay, let's continue. Okay, so the main idea of this problem is to complete the square so that we can see the center and the radius. Alright, so group the x together and then group the y together, group the z together. And then the 30 minus 35 we move to the right hand side becomes 35. Okay, now let's start to match. Minus 2 over 2 is minus 1. But minus 1 square, so we put here minus 1 square. Minus 1 square is the same as 1, right? So we also add 1 on the right hand side. Here, minus 6 divided by 2 is minus 3. So minus 3 square is 9. So we also add 9 on the right hand side. Here, 4 over 2 is 2. So 2 square is 4. We also add 4 on the right hand side. Okay, let's continue. So this guy is x minus 1 square plus y minus 3 square plus z plus 2 square. And what is the right hand side? 1 plus 9 is 10, so 45 plus 4, 49. Ooh, 49 is 7 square. And you see this is positive and it's great. And this is a sphere. So this is the sphere with the center. What is the center? Okay, so if it's x minus 1, the center, we have 1. Y minus 3, then we have coordinate 3. Z plus 2, then we have minus 2 in the z coordinates. And then the radius is 7. So far, so good, everybody. Do you have the same answer? Okay, let's continue to look at part C. So part C, so don't forget you can always try to work on the problems first and then continue to play the video. Alright, so we separate the x, y, and z. Okay, on the right hand side is 0. Then let's change another color. Start to match. Minus 12 over 2 is minus 6. Minus 6 squared is 36. Here 2 over 2 is 1. 1 squared is 1. Here minus 6 over 2 is minus 3. Minus 3 squared is 9. So far so good, everybody. Okay, so what do we get? This is the complete square of x minus 6. This is y plus 1. This is z minus 3. And then on the right hand side, we have 36 plus 10, 46. Okay, so because it's positive, then we also get a sphere. Okay, so sphere, what's the center? Can you tell me? 6 minus 1 and 3. How about the radius? Square root of 46. So far so good, everybody. Sometimes your radius might not be an integer. It could be an irrational number. Okay, so now we have seen the case of imaginary points, imaginary objects, and we have seen the case of sphere. When do we have a point? Okay, so let me use a different color. So when do we see a point? We see a point if our expression like x minus a squared, y minus b squared, plus z minus c squared, my parentheses, equals 0. If this guy is 0, then we actually get a point. So the point is A, B, C. So far so good, because on all of your left hand side is greater equals 0, greater equals 0, greater equals 0. So this equation equal to 0, it forces that each square, so each term must be 0. So that's why x is A, y is B, and z is C. So far so good, everybody. Okay, very good. Let's continue. Example, find the equations of the sphere with the center 7, 2, minus 5 that passes through the origin. Okay, so for this kind of problems, it's very good to draw pictures and understand what is happening. Okay, so we have the sphere. Okay, this is the center. Well, the center is 7, 2, minus 5, right? It passed through the origin. Oh, this is the origin. Okay, then what can we tell? In order to get an equation of the sphere, we need to know two things. One is the center, the other one is the radius. Can you find the radius in this case? See, it passed through the center. So the radius, you know, any point on the sphere to the center, the distance is the radius. So that's why the radius is the distance between the origin and the point 7, 2, minus 5. And this is the same as, okay, here, let me write it down. In general distance between 2 points. Okay, so let me use a different color if we want to write the formula. So, okay, so distance between 2 points. Let's say x1, y1, z1, x2, y2, z2 equals square root of x1 minus x2 squared, y1 minus y2 squared, z1 minus z2 squared. Okay, but in this case, because origin is just 0, so this is the same as the length of the vectors 7, 2, and 85. So 7 squared and 2 squared is 4, and negative 5 squared is the same as 5 squared. So 49, 4, and 25. That is 78. Okay, now we know the center, we know the radius, we're ready because we have x minus the x coordinate of the center, 7 square, y minus the y coordinate of the center, 2, and z minus -5 is the same as z plus 5 square, equals the radius square, which is 78. So that is part A. So far so good, everybody. So sometimes it's very useful to draw the picture and then try to figure out, okay, what do we need here? Okay, let's continue. Part B, find the largest and the smallest distance between the points 4, 9, -6 and the surface of the sphere. Okay, so let's see. Here we have a sphere. Okay, this is the center of the sphere, and we have a point. Okay, we have a point here, and we want to find the largest distance and the smallest distance. Okay, what do you say? So we draw here. Okay, so what is the largest distance? What do you say here? So the largest distance, it should be, let's say this line passed through these 2 points. Okay, and then let's say we know this is R, right? And here to find this point on the sphere is kind of hard because you need to find the line and then the sphere, and then you do intersection. That's hard, but think about it. The center we know, so to find the distance from the point to the center, we know how to do it, right? And then we also know the radius. Well then, what is this guy? D minus R, right? That is the shortest distance. And how about the largest distance? D plus R is the largest distance. So you see, it's very easy. We don't need to find the points where it intersects the sphere, and then we can find the largest distance and the shortest distance. Okay, so first thing is we want to figure out what's the center and what's the radius, right? Then just did what we were doing, right? We want to write down the complete square form of the each of the coordinates. So x squared, then we have the minus 2x. Then we have the y squared minus 6y, and then we have the z squared plus 4z equals, we move the 35 to the other side, it becomes 35. Here minus 2 over 2 is minus 1, minus 1 squared is 1, minus 6 over 2 minus 3, minus 3 squared is 9. Here 4 over 2 is 2, 2 squared is 4. Okay, so here we have x minus 1 squared, y minus 3 squared, z, sorry, my z really looks like a 2. Okay, this is z, this is 2. And how about the right hand side? 35 plus 10, 45 plus 4, 49. Okay, so what is the center? 1, 3, 2. So far so good, everybody? Oh, sorry, this is 2, okay, so this is minus 2. Yeah, sometimes it's very important to check our answers. It's always very important to check our answers. Then R is the square root of 49, which is 7. Great. Now we have to figure out D. D is the distance from the center to the points 4, 9, minus 6. So we use 4 minus 1, 9 minus 3, and then we have minus 6 minus negative 2, so plus 2. Okay, what is that? 4 minus 1, 3, 3 squared, 9, 9 minus 3, 6, 6 squared, 36, minus 6 plus 2 minus 4. Minus 4 squared is 16. Okay, add them or up, then what do we have? So let's see. 36 plus 16 is 52, plus 9, 61. So far, so good. Okay, so what is the shortest distance? D minus R. So square root of 61 minus R is 7. And how about the largest? Square root of 61 plus 7. And that's it for this problem. Notice that square root of 61 is bigger than 7, so both numbers, they are positive. So far, so good. That could be the case that the point is inside the circle. So let me ask you, what happens if the point is inside the circle? Okay, so you have the center, you have the points, and what happens if it's inside the circle? Well, then let's see. What is the largest distance and what is the shortest distance from this point to the sphere? Okay, sorry, not sphere, not circle. So this is D. Okay, then this shortest distance is R minus D, right? How about the largest distance? Largest distance is still D plus R. So far, so good, everybody? So sometimes we draw the picture, then we can figure out. All right, let's continue. Find the values of A and B such that A plus 1 minus 2, 2B plus 3 is orthogonal to both vectors. Okay, now let's see. So let's call this guy as U, this is V, this is W. Okay, because it's orthogonal to both vectors, so U dot V is 0. Okay, what is U dot V? So A plus 1 times negative 3 minus 2 times 1, and then plus 2B plus 3 times minus 2 equals 0. Okay, let's figure out what is this. Minus 3A minus 3 minus 2 minus 4B minus 6 is 0. Let's move the A and B on the right hand side. So we have 3A plus 4B minus 3 and minus 2 minus 5 minus 6 minus 11. So far, so good, everybody. So we get one equation, 3A plus 4B equals minus 11. Okay, and here we have two unknown, A and B. In order to solve two unknown, we need to have two equations. Okay, so the U dot V equals 0 give us one condition. The other one, U dot W equals 0 can give us another condition, right? So U dot W is 0. So we get A plus 1 times 1 minus 2 times 4 plus 2B plus 3 times minus 1 equals 0. So let's distribute it and combine the like terms. So minus 2B and minus 3. Oh, this is the same as a minus 2b. Let's move the constant to the right hand side. So 1 minus 8 is minus 7, minus 3, minus 10. But when we move to the other side, it becomes 10. See, now we have get two equations. 3a plus 4b equals minus 11. A minus 2b equals 10. So far, so good, everybody? Ooh. I wrote a lot, so I don't have enough space. Okay, it's okay. Here we can use the elimination method. We can choose to eliminate A or we can eliminate B, right? I think eliminate B is easier because we just need to multiply the second equation by 2. Then we have 2a minus 4b equals 20. And then we can then add equation 1 and 3. So 3a plus 2a is 5a. B cancel. Minus 11 plus 20 is 9. So we have a equals 9 over 5. Wow. And then how do we find b? We can plug in either equation 1 or equation 2, but plug in equation 2 looks like easier. So 9 over 5 minus 2b equals 10. Negative 2b is then 10 minus 9 over 5. The common denominator 5. 50 minus 9 is 41 over 5. Then b is negative 41. 5 times 2 is 10. Okay, so now we have find the values a and b. A is 9 over 5 and the b is minus 41 over 10. Okay, so now we have finished sessions 11.3. So we learned about dot products and the projection, and we also review some geometry in the space. Okay, so if you have questions, feel free to ask me in class or office hours or email me. Okay, please continue to work on your homework. Have a nice day. Bye.